With the name of Allah Almighty, dear students and all viewers, may peace be upon all of you. Hopefully, you all will be fine. I am Dr. Engineer Majid Amin, subject specialist mathematics from Peshawar, Pakistan, and my YouTube channel is maths.physics. We have started this course, 9th class mathematics. Chapter is matrices, and today is the 5th lecture in English. I record my lecture both in Urdu and English, so today is the English. And the topic which we are going to discuss is multiplication of matrices. I hope that you have gone through the previous lectures. The link is there. Otherwise, the whole playlist is in the description. Students, let's get started. Multiplication of matrices. What do I write? Okay, students. Two matrices. Let's say those matrices are A and B. Two matrices are said to be conformable for multiplication or fit for multiplication or suitable for multiplication, or you can say the multiplication of two matrices is possible if and only if number of columns of first matrix is equal to number of rows of the second matrix. So my dear students, let's say these are two matrices A and B. The condition for multiplication is that number of columns of this is equal to number of rows of this matrix, second matrix. If you have watched my previous lecture, there we discussed addition of matrices. So the condition for addition of matrices was the size of the two matrices should be same. Like this is matrix A, the second one is matrix B. For example, this is 3 by 2 matrix. Let's say this is 3 by 2 matrix and these are the elements or the entries. 4, 1, 0, 9, minus 8, 6. It is 2, let's say 3, minus 1, students minus 5, 2, and for example 4. These are two matrices and they can be added. Its size is 2 by 3. I'm sorry, 2 rows and 3 columns, and its size is also 2 by 3. So we can add these matrices, and by addition we meant adding their corresponding elements. What is meant by addition of matrices? Add their corresponding elements, like we will add these two corresponding elements in the same elements having the same position, like this is in the first row first column, this is the first row first column. So these are corresponding elements and we have to add them when we want to add two matrices. So 4 plus 2 is 6. Likewise 4 minus 1, 4, my students, this is the result. But here the condition is that it is not necessary that the size should be same. Number of columns of first and number of rows of second will be equal. If someone tells me that multiply these two matrices, so it is not possible to multiply them. Why? We will discuss in a short while, but it is not possible to multiply them. Why it's not possible? Because it has 3 columns and the second matrix has 2 rows. The condition is not fulfilled. Number of columns of first must be equal to number of rows of second. So it is the first thing. So let's take two matrices, like this is the matrix A. For example, my sweet students, this is matrix A. Okay, I can remove this. There's no need. I wrote number of columns of first. What is meant by first? The matrix which we write first in multiplication will be all first matrix. For example, my sweet students, this is matrix A. 2, 1, 3, students 4, minus 1, 1. This is matrix. And this is another matrix. How many columns it has? It has 3 columns. The second matrix should have 3 rows. It has 3 columns. It should have 3 rows. Let's say those are 5 students, or this is, let's say, let me take simple numbers, 4, and this is for example 1. Students, I write 2, 1, and 3. Let's take it negative. Now the size of this matrix is 2 by 3 and the other matrix is 3 by 2. Now these two matrices are fit for multiplication. Why? Because number of columns of first a number of rows of the second matrix are equal. Forget about these two. You would be thinking, sir, number of rows of first and number of columns of second are also equal. Forget about this. For after a short while, I will change this. I will make it 3 by 4 matrix. But since it is ninth level, I want to take simple matrices. Just forget about these two. It's not the condition. Condition is that these two will be equal. This one, number of columns of the first and number of rows of the second. Now, why? Why is it so? Because students, how we have defined matrices by multiplication of two matrices, we mean that the number of rows of the first matrix will be multiplied with the columns of the second matrix. And what does it mean? That multiplication of rows with columns. Multiplication of rows with columns means that first element of the row will be multiplied with first element. Second element will be multiplied with second element. Third element will be multiplied with third element, and so on, and then they will be added. For example, they are A, B, C. Students, X, Y, and Z or Z. So if you want to multiply this row with this column, multiplication will mean A into X, first element of the row with first element of the column, second element of the row with second element of the column, by, and similarly these two cz, and then they will be added. This is how we have defined multiplication of a row with a column. For example, I want to multiply the row having elements 2, 1, 3 with column having elements 5, 4, 1. So how will we multiply them? Multiply these two, first element with first element, of course, of row and column. So it will be 2 times 5. Then we will multiply these two 1 times 4, and then these two 3 times 1, and then they will be added. So it will give me 10 plus 4 plus 3. The result will be 17. So students, if we want to multiply them, AB 213, multiplication of matrices is defined in this way. Multiplication of all the rows with all the columns turn by turn. For example, students, I mean that multiplication is not defined like multiply the corresponding elements of the two matrices like we have done in addition. It is not defined in this way that their multiplication will be 4 multiplied by 2, 8, 1 multiplied by 3, 3, 0 multiplied by minus 1, 0, minus 45, minus 16. No, no, it is not defined like this. Why? It is predefined. So now let's come to the multiplication. First row multiplied with first column. Multiply these two. 2 multiplied by 5 plus these two. 1 multiplied by 4 plus 3 multiplied by 1. Now first row will be multiplied with second column, and the same trick. 2 multiplied minus 2. First element with first. Second element with second, and third element with third, and of course their addition. Now it is finished because we don't have third column. If there was another column as well, and we would have multiplied first row with that as well. Now let's come to second row. Multiply with first column. 4 times 5 plus minus 1 times 4 plus 1 multiplied by 1. You got me? Students, second row, second column, 4 multiplied by minus 2 plus minus 1 multiplied by 1 plus 1 multiplied by 3. Now you can add them. It is 10 plus 4 plus 3. Students, this one 20 minus 4 plus 1. This one minus 4 plus 1 plus 9, and minus 8 minus 1 plus 3. Okay, my sweet students, this is 17, 6, 17 by chance, and this is minus 8, minus 10. Towards minus 9, minus 9 plus 3 is minus 6. By chance, we got this result. Okay. You got me? This is the result of multiplication of these two. Now, remember that if A is M by N matrix, we have two matrices A, B. Let's say its size is M by N, having M rows and N columns. And is another matrix which has N rows and P columns. That's what I mentioned at the beginning. These two may be equal and they may not be equal. I use different alphabets. Matrix A has M rows, matrix B has P columns, but matrix A has N columns and matrix B must have N rows if you want to multiply them. Then this is the condition. And if you multiply them, of course, you will get another matrix. You will get another matrix. This matrix will have the size M cross P, means that C will have M number of rows and P number of columns. Let me check whether it is within the range of the camera. Yes, it is. M by P. For example, in that particular case, matrix A has the size 2 by 3. Matrix B has size 3 by 2. So they have to be equal for multiplication. And if they are equal, multiplication is possible. And if multiplied, the two matrices are multiplied, the resultant matrix will have this size C. It will have size 2 by 2, and you can see the resultant matrix is 2 by 2 matrix. For example, the size of matrix B is 3 by 4. 3 by 4. Then the resultant means if we multiply A and B, the condition of multiplication is fulfilled. The resultant matrix will have the size M cross P. Now you see M number of 2 number of rows and 4 columns in the second matrix. They are different. Multiplication is possible due to the inequality of these two columns and rows. The resultant matrix will have size 2 by 4. Let's check. Now I will skip this step. I mean that if I want to multiply them, now you know the basic method, the methodology. Otherwise, if we have more number of columns, it will become a bit difficult for me to write them in proper way. But we can reach at this at once without skipping that step. If you want to multiply this row with this column, multiply this row with this column, you can perform this multiplication like this. Just multiply them. 2 times 5, 10, plus 4, plus 3. 10 plus 4 plus 3. First row, second column, minus 4 plus 1 plus 9. Minus 4 plus 1 plus 9. That's it, finished. Now second row, first column, multiply them. 20 minus 4 plus 1. 20 minus 4 plus 1. Minus 8 minus 1 plus 3. Minus 8 minus 1 plus 3. You got the point? Okay. So let's take different matrices. Let's change matrix B a bit. I mean, let's take 4 columns in this matrix. Like I write 3, 2, 1, 1, 4, minus 5. You got it? Okay. And let me change this number as well. Let's make it 10 so that we get different results. Okay, students, now the size of B is 3 by 4 matrix. It is matrix B is, the size is 3 by 4. It is 3 by 4 matrix. Multiply them. 2, 1, 3. 4 minus 1, 10. This is matrix A. Matrix B, 5 minus 2, 3, 2. 4, 1, 2, 4, 1, 3, 1 minus 5. First multiply first row with first column. 10 plus 4 plus 3. 10 plus 4 plus 3. Take one element as 0. Let's take this element 0. First row, second column, multiply them. Minus 4 plus 0 plus 9. Minus 4 plus 0 plus 9. First row, third column, 6 plus 2 plus 3. 6 plus 2 plus 3. Last one. First row, fourth column, 4 plus 4 minus 15. 4 plus 4 minus 15. Now, second row, first column, 20 minus 4 plus 10. 20 minus 4 plus 10. Minus 8 minus 0 plus 30. Minus 8 minus 0 plus 30. 12 minus 2 plus 10. 12 minus 2 plus 10. Last one. 8 minus 4 minus 50. 8 minus 4 minus 50. You got the point. 17, 5, 11 minus 15. This to 30 minus 4, 26, 22, 20, and this is what? Minus 54. 4 minus 50 minus 46. So you see, it is 2 by 3 matrix, it is 3 by 4 matrix. The resultant matrix is 2 by 4. Hopefully it is clear. Now you must be thinking, why? Why number of columns? Students, because number of columns, we are multiplying row with column, which further means first element with first, second element with second, and third element with third. So number of columns actually shows number of elements in a row. It's not possible to multiply these two matrices, 2, 1, 3, 4, 6, 7, 4, 9, 8, 7, 6, 4. Why? Because if you try to multiply them, first row will be multiplied with this element, will be multiplied with this. Okay. This will be multiplied with this. Well and good. What will be multiplied with this? The corresponding number for this third element is missing. So actually number of columns means that number of elements in a row. You could also say that number of elements in rows of A will be equal to number of elements in row must be equal to number of elements in columns. Here we have 3 number of elements, and in the second matrix we have 3 number of elements in the column for the second matrix. Number of elements in column of matrix B. Number of elements in a row means number of columns. Like there are 3 number of elements in a row, it means this matrix has 3 columns. And we have 3 number of elements in a column. So you could also say that A multiplied by B will be possible if number of elements in rows of A will be equal to number of elements in column of B. Last time I repeat, number of elements in a row means number of columns, and number of elements in column means number of rows. Like I repeat these, I eliminate these two. So now this matrix has how many elements in the column? It has 2 elements in the column, means it has 2 rows. Hopefully you got it. Now, my sweet students, I am longing for recording all my lectures, but definitely it will take time. Students, this is a simple MCQ. All right, students, what did I write? Which law does not hold in matrices? Multiplicative law of addition. Students, in the previous lecture, you discussed that this is called commutative law of addition, and it holds in matrices provided the 2 matrices are suitable or conformable for addition. Similarly, if addition is possible, this is called associative law of addition. And this is called distributive law of multiplication over addition. So in matrices, in addition, commutative law, associative law, and distributive laws, the 3 laws they hold. But for multiplication, commutative law of multiplication, this one, associative law of multiplication, this one, and distributive law, this one. This law does not hold. AB is not equal to BA. But we say generally it is not equal. What does it mean generally? It will be discussed in a short while. But law is a thing which always holds. AB is not equal to BA generally. Generally means in majority cases, like you say for your simplification. Otherwise, if you are experienced, no need to explain this. But generally means Like you can say in 98% cases, they will not be equal. There are rare cases in which AB and BA can be equal. Rare cases. We will give examples. In 99% cases, or in majority of cases, you can say, but majority is 60% and 40%. An overwhelming majority. An overwhelming majority, AB and BA will not be equal. But if you don't mention this word, it means that AB and BA are not equal and they are always not equal. So it's wrong. In rare cases, they may be equal. So that's why we say AB and BA not equal generally. So you can't say commutative law of multiplication. Sometimes it holds and sometimes it doesn't hold. Law is something which always holds. Even if it is failed in 1% cases, you say that this law doesn't hold. Commutative law of multiplication does not hold in matrices. You got me? Okay. There is four simple matrices given in front of you. To black marker, I give the task, please calculate AB. And to the blue marker, I give the task, calculate BA. So you take A first. 6, 3. Okay. Before this, let me give you another example. For example, my sweet students, this is matrix A. 4, 3. This is matrix B. Students, 1, 6, 2, 5. I said to one student, please calculate AB, and to the other student, the task is calculate BA. So here you can see that AB is not possible. You can't multiply AB. It's not possible because it is 2 by 1 matrix, it is 2 by 2 matrix, number of columns of first and number of rows of second are not equal. So it's not possible to multiply them. But BA is clearly possible if you take matrix B first and matrix A second. It is 2 by 2 matrix. It is 2 by 1 matrix. Number of columns are first and number of rows of second. It's possible to multiply them. And if you multiply them, first row multiplied with first column, 1 multiplied by 4, 4, 6 multiplied by 3, 18. Second row, first column, 2 multiplied by 4, 8, 5 multiplied by 3, 15. It is 22 and it is 23. So one problem is this. Maybe it's possible that AB can't be multiplied and BA can be multiplied. One is this problem. The second problem is maybe both are possible. When will this happen? For example, if they have same sizes. AB will be possible, BA will be possible, but the problem is that there is 99% chances that they will not be equal. Likewise, this AB, like in this example, AB 6, 3, 2, 5, matrix A. This is matrix B, minus 3, 2, 1, 5. Multiply them. Multiply them, my sweet students. First row, first column, minus 18 plus 3. Minus 18 plus 3. I hope you know how to multiply them. Oh, okay. First row, second column, 12 plus 15. 12 plus 15. Second row, first column, minus 6 plus 5. 4 plus 25. This is students. This is minus 15. 27 minus 1, 29. BA. BA minus 3, 2, 1, 5. A 6, 3, 2, 5. Multiply them because order makes a difference in this case. First element is multiplied with first. So if you interchange them, maybe in the previous cases you are multiplied 2 with 3 now, and here you will multiply 2 with 4 because the order has different elements. First row, first column, minus 18 plus 4. You can clearly see. Minus 18 plus 4. Now these two, minus 9 plus 10, 6 plus 10, 3 plus 25. You got this matrix, minus 14, 1. Students, 16 and 28. So they are clearly not equal. AB and BA are not equal. 6325, 6325, minus 3215, minus 3215. This slide, for example, missings or mistakes, please fix them. But AB and BA will not be equal in majority cases. So now if CD students, CD and DC, they will be equal. So you see, but in rare cases, it will be like this. You calculate CD, I will calculate DC. CD. Both are possible, means multiplication 2, 2, 3, 5. Matrix D is 2, 2, 3, 5. C 1, 2, 3, 4. Multiply them. My sweet students, it will be 2 plus 6, 2 plus 6 now. 2 plus 10. Then 6 plus 12. Then 6 plus 20. 8, 12, 18, 26. DC. First row, first column, 2 plus 6. Then 4 plus 8. Then 3 plus 15. Last one, 6 plus 6 plus 20. Okay, so you got 8, 12, 18, 26. You can clearly see that they are equal. So you have to mention AB is not equal to BA generally, means in majority cases they will not be equal. We don't say majority or minority, but we say generally. Generally it is not equal. Okay, students, associative law of multiplication, it holds. Like these are the previous matrices, they will always be equal. A times BC and AB multiplied with C, they will be equal. You will see. First calculate BC. First calculate BC. This is B minus 3, 2, 1, 5. And this is C 1, 2, 3, 4. You got the students, you got the point. Multiply them. Minus 3 plus 6. Minus 6 plus 8. Then 1 plus 15. And then 2 plus 20. Students, it is 3, 2, 16, 22. It is BC. Now, A multiplied by BC. A multiplied by BC. This is matrix A, 6, 3, 2, 5. And BC is 3, 2, 16, 22. This one. 16, 22. Just multiply them. First row, first column, 18 plus 48. 18 plus 48. Now, students, okay, in progress. These two, 12 plus 66. 6, you can take simple matrices for yourself. 6 plus 80. So you don't come across these huge numbers. A bit difficult for you. 4 plus 110. Right, students? So you got 8 plus 8, 16, 1, 4, 5, 6. 8, 78, 86, and this is 114. Now you determine right hand side. Right hand side AB. 6, 3. B. Minus 3. First row, first column. First row, first column, minus 18 plus 3. Then 12 plus 15. Minus 6 plus 5. 4 plus 25 minus 15. 27 minus 1, 29. This is AB. Finally, AB multiplied by C. This is AB minus 15, 27, minus 129, and C. 1, 2, 3, 4. So let's multiply them. Minus 15 plus 27 multiplied by 3 students. 81. Minus 30 plus 27 times 2, 54, 108. Now students, minus 1 plus 29 multiplied by 3, 7, 2, 3 times 2, 6, 87. These two, minus 2 plus 29 multiplied by 4, 6, 3, 116. Now if you simplify them, you get 66. Students, 78, 86, and this is 114. So you see they are equal. Then finally you have to write from 1 and 2. It is clear that A into BC is equal to AB into C. You have to mention. This is, students, associative law of multiplication. Now finally it is distributive law. All right, students, distributive law, A into B plus C will be equal to AB plus AC. And for simplicity, to save time, let's take simple numbers so that the numbers are not too big for us later on. Main thing is just verification of this law. So first you calculate left hand side. For that you must add B and C. Minus 3, 2, 1, 4, B and C. 1, 2, 3, 3. Let's change it. Let's make it minus 1. Minus 1 plus 3. Add them, students. You get minus 2, 4, 0, 7. This is B plus C. A into B plus C. A 4, 3, 2, 1 into B plus C. Multiplication. Minus 2, 4, 0, 7. Students, multiply them. Multiply them. Minus 8 plus 0. I write directly minus 8 plus 0. 16 plus 21. These two, second row, first column. Minus 4 plus 0. 8 plus 7. Minus 8. Students, 37. Minus 4, 15. This is the left hand side. Now my sweet students, the right hand side. AB 4, 3, 2, 1. AB minus 3, 2, 1, 4. Multiply them. Minus 12 plus 3. First row, second column. 8 plus 12. Minus 6 plus 1. 4 plus 4. Minus 9, 20, minus 5, 8. This is AB. Now students, AC. AC. Matrix A, 4, 3, 2, 1. AC. 1, 2, minus 1, 3. AC. Multiply them. 4 minus 3. 8 plus 9. 2 minus 1. 4 plus 3. So it will be 117, 17. Finally, AB plus AC. AB plus AC. Finally, AB minus 9. AC 117, 17. Add them. Minus 8. 37. Corresponding elements addition. Minus 5 plus 1 minus 4 and 15. This is your equation number 2. This is your result number 1. So then you finally have to write from 1 and 2. It is clear that from 1 and 2, it is clear that A into B plus C, AB plus AC, hence proved. Right, students? Now, in the next lecture, I think it's enough for this lecture. In the next lecture, we will discuss additive, multiplicative identity, multiplicative inverse, because it will require a lecture of about 40-50 minutes as well. So this lecture will become too lengthy if we continue from here. Enough in this lecture. Students, I hope you got the basic idea how to multiply two matrices and which laws hold in multiplication of matrices and which law doesn't hold. Hopefully, you got the main idea. Let's meet in the coming lecture. Till then, remember when your prayers. God bless you.